Today I'm going to write a little Rust program. It's part of my learning how to program in Rust project. And if you don't know, Rust is the new computer programming language written by the guys over at Mozilla. They're going to be using it to write their new browser called Servo. It's all about safety, concurrency. The compiler is very pedantic. It makes it kind of a challenge to learn the language, but it's also a lot of fun because it gets you kind of back in touch with the operating system. You have to be a lot more explicit about your data types and everything, and that makes it a lot more challenging, but it also gives you all the benefits like a lot more memory safety, performance, various other things, access to modern sort of programming language features, and we'll go over a few of those. I'm going to try to go pretty fast just to try to keep this nutrient dense, I guess. So the first thing I'll just bring you to the home page for Rust. It's rust-lang.org. You probably are running on an operating system that can use Rust, so get your version of Rust. I'm not going to go into that. Get your environment kind of basically set up so you can run the cargo command, and then we should be off to the races. I will. What we're going to do in this, what I'm going to write a program for, is to generate one of these Sierpinski triangles. I'm going to do it kind of in memory, and then I'm going to write that out to a PNG file. And it's a really simple algorithm I'm going to be using, same one I learned back in college a long time ago, called the chaos game method. Essentially, we have a triangle, points A, B, and C. We pick some random point to start at, and then we start this loop where while we got our marker down at that initial point, we select at random one of the 3 points, A, B, and C. We calculate the distance halfway between our current location and one of that randomly selected vertice, and then we go there and drop the pen again. And we just keep repeating that, and those little dots will eventually form a Sierpinski triangle. So that's what we're going to do. And so I'm going to be using this package called Image. It's a really cool image processing library that's not too big, and it's very it's very easy to use, all things considered, even for a newbie to Rust like me. So I'll show you some things we can do. I highly recommend, if you need to do any image processing in your programs, this seems to be a pretty neat one. It kind of gives you some of the things you can do in ImageMagick, but in your own program. And it's probably safer than ImageMagick, given that we had a couple high visibility security issues with ImageMagick this year. Anyway, enough of that. I'm just going to go forward here and get my shell open. I'm in my working directory here. First thing I'm going to do is I'm going to use the cargo command to create a new project. So it's cargo new, and then the name of the project, which is going to be called triangle, and I will say bin, meaning that this package is going to be designed to create a binary. So go into triangle, and it automatically put this under source control management for me. That's awesome. First thing I'm going to do is edit this cargo.toml file. This is sort of like a bundler file in Ruby, I think. Similar thing exists in Node. I think that Node.js uses like a packages.json. Anyway, this is just where we list dependencies, and Rust still has dependencies. We don't have to write everything ourselves. And I'm just going to try to get away with saying use image and use rand. I'm going to need some random number generation love in order to randomly pick one of those 3 points, like I said. Okay, enough of that. I shouldn't have to muck with that much more. Now I'm going to switch editors and bring up this scaffolding file. When you run cargo, it creates some basic scaffolding. I can run, this is what it looks like. You have your current working directory, cargo.toml file, and then a source directory to start with. And they populate that main.rs file. .rs files are Rust files. They populate that with just a hello world example. So most of the time you'll just be doing this. Okay, so another really cool thing about Rust is inline documentation will produce kind of usable documentation, whether it be for API or just general documenting your code. Not only in the code, inline, but it will also generate HTML output that's the exact same stuff that you see when you look at the documentation pages for Rust online. So it's pretty neat. Just a couple key points here. The // prefix is a normal comment in Rust, just like C++. But if you do /, the ones that have 3 slashes are for automatically generated documentation. However, at the beginning of files or anywhere else in the file, if you want to do sort of out of context documentation that just is in line with in the HTML, you can use //bang, and that's what I'm doing here. And so I can say, Sierpinski Triangle Image Generator. And now that will actually show up on the front web page when we get around to doing that. And I could say, main program here, for example. However, that wouldn't show up in the documentation because this isn't public. But I could make it public like that. And that would make it show up. Anyway, hopefully I'll get to show you that. So first thing I'm going to do is I'm going to bring in my external dependencies here. Again, you saw me add these in the cargo.toml file. Crate is the package manager, so they're called crates. And I'm just going to say what I'm going to use here. These are all documented online, so that's how I figured out what to use. Some of these patterns aren't as nice as Python and Perl for working with files and things like that, but I guess once you write the basics, you can keep on reusing your code and it's not too bad. Oops. And so I'm going to create a structure here, just using, why not, I'll make it public so we can document it. And I'm going to change mine to unsigned 32 for reasons that you'll see in a little bit. The image library I'm going to be using is uses unsigned 32s. Oops, it's a curly brace, I think. So I could put here, points used to build the triangle and plot points on the canvas. I think I can do this. Yes. So that document, that will actually show up as part of the documentation for the point structure, which is kind of neat. All right. The other thing I'll show off here is that they do have constants in Rust. Kind of similar, except for you can call out their types. I'm going to use 800 by 600. Oopsie. So it fits in my little window here. And here we go. We are going to I'm going to create a mutable variable called img. Image buffer, I think, yeah. And we're going to use a closure here. And so the syntax might look a little odd to you. What I'm doing with this loop is I'm pre-populating the image buffer with all white RGB basically, except for 1 pixel that I'm going to use later. You'll find out why. So you've noticed that Rust likes you to explicitly declare what type of primitive that you're using. So here I'm using an unsigned 8-bit value. That's what this particular image format likes. And you'll also notice that I just ended that if block without a semicolon, and that's on purpose because that will be the result, and it's essentially kind of an early return. It's a return, and since there's no semicolon, it's no longer a statement in Rust, it's an actual value, so that gets emitted and sucked up into that closure. End our if block, and then we'll end this, this. Okay, again, we need to do this a few thousand times to get the image to kind of congeal and come into view, so I will have a counter. We'll specify what type it is and use another feature of Rust where we can add some pretty printing syntax to our numbers that are big so we can see how big they are. So I'm going to do 10,000 iterations, and then I'm gonna define the points of our triangle. This is an array, a fixed size array, so it's not a vector, which is variable. It goes on the heap. It's going to have 3 points in it from our struct. And I'm going to basically just points on the edge of the rectangle. Yes, that looks right. So essentially the first point here is top of the image right in the center, and then these other two are the lower and right, the bottom corners of the rectangle. I'm just going to pick an arbitrary point to get us going here. And P is going to be where my pen is as I write on the image. So that's just a random starting point. And then num is going to be an unsigned item that I'll use for indexing into my array that I just created up there. As a matter of fact, I might move that up here because it's kind of more related to that. And then I'm going to start, oh yeah, one more thing. I need to get a prototype pixel to use to populate these coordinates with on the image. And this is kind of janky, but I don't know else how to do it yet because I didn't have time to finish reading the documentation. So I'm just going to steal that one pixel that I created earlier that was black at 0, 0, and I'm going to use that as the one that I replace on the screen. So I'm kind of cheating there. I'm definitely cheating. Okay, now I'm going to start my loop. This will probably look familiar. Finally get to use my random number. So this is the simple math to create the midpoint between 2 points. And this member function for the image buffer type is pretty self-explanatory. That's why I found that to be pretty easy and nice. Basically, just put the cursor down there and drop the pixel in place. Eventually, I suppose we could augment this to be color and stuff. That'd be kind of neat. And now we're going to generate an image from this in PNG format, and I think this is pretty cool. Here we're going to open up a new file and get a file descriptor for it. This is somewhat crazy, not very nice looking, but again, I'm sure I'll get used to it. So the way I understand this is that this gets me a file descriptor named f out, I meant to say, from the standard library methods. From this path method, path I guess returns me a system path, a file system path, to a file named tri.png, and it does basically probably an open with the create flag set. And then the unwrap is sort of a way of just sort of saying I don't want to do proper error handling right now with like a try except type of thing. I'm just going to use unwrap. We're not going to bother doing fancy error handling yet. And then this is where we use the image library again to take whatever we have in our buffer, img, and turn it into a PNG file in this case, but they support multiple formats. Here's my file descriptor. So I'm going to save it to f out, and then I guess this is a constant or something over there, at image : PNG within that library. And that's it. So the reason I assign this to something is that the Rust compiler will complain if we run this command without catching its return value. And underbar is this sort of catch-all variable that you can use for that. Okay, I probably made a mistake with this, but let's just go ahead and try to compile it. So to compile it, we just type, let me move this window up a little bit. There we go. So I'm going to do cargo build, and we'll see what happens here. So it's compiling all of the dependencies, which is quite a few. So Rust is definitely like some of the other ecosystems today in that it's has a lot of dependencies when you write code with it. The good thing is that it's kind of like Go in that those dependencies are on the developer side and less on the deployment side. Okay, so the last item up there in the screen is it compiled the triangle package, which is what we just wrote, and wow, it worked the first time. I don't know if it's actually going to work, but let's give it a try. So I'm going to break out of Emacs here. I'm going to run this. You just do cargo run. By default, that's going to run the debug version of the code. And so I'm just going to go ahead and run it and see what happens. Okay, it completed, so I should have a, let's just run tree dot here and see if I have an image file. I do. In my working directory, I now have a PNG file. Let's see how big it is. It's 24K. And if I do file on try.png, it says it's a grayscale, non-interlaced, 800 by 600 PNG image. Cool. Well, let's open that up and see what it looks like. Wow, and there's a triangle. Let's try this with a little bit more, some more iterations. Let's do a million iterations. See what it looks like. And we'll recompile it. Okay, that's all done again, and then we will run it by running cargo run. And then we will open the image. Okay, that looks a lot better. So a million looks really good. Okay, so let's take a look at this binary real quick. So when we run cargo run, what it does is it runs, look at the output here. There's a target directory. That's new now. Right here. And under target debug build, I think there's a bin directory. Oh no, it's just in target. So let's go in there and take a look. So in target debug, oops, there is a binary in here, triangle. It is basically 1.3 megabytes. It is 64-bit executable, and this is the debug version, that isn't too bad at all. And if I go up a directory, if I go back to the main directory here, I think I can do cargo run -- release. Now it's going to do two things. It's going to rebuild everything with the debug information turned off and it being optimized, and I should have a little bit different hierarchy underneath target after this. So it looks like it's recompiling a lot of stuff for release. Looks like it's recompiling everything. I have heard that Rust's compiler can be kind of slow, especially on really, really big projects. But you know, it does check the dependencies on whether or not recompilation is actually required. But this is just, it's redoing it all right now. It's not redoing it, it's actually just doing it for the first time. So anyway, the next video I'm going to do is I'm going to be working with this library called Piston, and it's a game development library in Rust. And so my next project will be to kind of build a game board, a 2D game board. I'm going to try to replicate a game from 1979, 1980 in Rust, and hopefully show you some of that progress. Okay, so so now we have a target release directory. So going to target, we have our debug directory that we went into before, but now we have a release one, and now we have this triangle one here, binary, and now it's only 400K. So it was 1.3 meg or 1300K, and now it's 400K. So it's a lot smaller. And we should probably test it, huh? So let's go up and see if our image looks the same. I will do cargo run -- release, I think. Okay, so we should have a new try file. Yes, we do. And we'll go ahead and do a open try. It looks about the same. Since this is generated randomly, I guess they're probably never quite the same. Anyway, thanks for watching. It's my first screencast. I'm going to, again, sorry for the audio. I know I don't have a good studio or anything, but if you like this, I'll be, I want to do one more thing. Let's say we like our project. We can do the following. We just do git status. We go ahead and do, it's got everything in there that we really want it to upload, except for I would add to .gitignore one thing. I would add, I don't want to include this. So the other thing I would like to do is do so let's just go ahead and do a git add git commit minus some initial commit. And now we can push it up to GitHub. It's pretty neat. The other thing I wanted to quickly show you is cargo doc. So I had those doc strings in there. I'll show you what happens now. inside the target directory, there will be a doc directory now. So we've had debug and release, and now we have doc. Inside the doc directory, there is documentation for all of the dependencies and our project. So our project was called Triangle. So there is our index.html. So if I just open that up, I'll open up index.html and look at it. This is what it looks like. So there's the comment from the first line of my main.rs file. Here's that public struct point that I put in there. Again, it wouldn't be shown if I hadn't put the pub in front of it. I can go look at main, and again I made it public even though it's not something I would normally document, unless it was maybe somebody needed to use it for an entry point from API or something. I don't know. Anyway, that's pretty it. It's a pretty neat ecosystem. It's a lot of fun to program in so far. It's just a little more challenging. The compiler's really pedantic, and I saved you from most of that tonight. So take care.